Hello, I'll be solving a related rates problem. The problem states that the hands on a clock are approximately 3 meters and 2.5 meters in length. How fast is the distance between the tips of the hands changing at 9 o'clock? That's what I've drawn here. We'll call the distance between the two hands is c. We can figure that out real easy using the Pythagorean theorem, and that'll just tell us that distance at 9 o'clock. So we have 2.5 squared plus 3 squared, square root of that equals about 3.9. So we need to relate this length to this angle, and that would be the law of cosines. So we're going to take the derivative of that, and a and b are constant, so those just become 0. So we get 2c by dc dt equals, and 2 times 2.5 times 3, we get 15. And it'd be negative, except that the derivative of cosine is negative sine, so we end up with 15 sine theta by d theta dt. And we know the length of c at 9 o'clock, and all we have to do is figure out the rate and change. We know that the minute hand has a rate of 2 pi every hour, and that the hour hand is 2 pi every 12 hours. So the rate of change between them would be the rate that the minute hand is moving minus the rate of the hour hand moving towards it. So we have the rate of the minute hand minus the rate of the hour hand. That becomes, well, here, let's simplify this first so that it's just, that becomes pi over 6. And this would be then 12 pi over 6. Ends up being 11 pi over 6. And that's the rate and change in c. So we know the length of c at 9 o'clock, we know the length. The rate of change in c, we know theta at 9 o'clock is simply 90, or pi over 2. So that leaves us with the only variable left, and that's the change in the angle, and that's what we're looking for. So this ends up being 2, the length of c, which is 3.9. The rate of change in c is 11 pi over 6, and that equals, well, let's divide out the 15 sine theta, and theta is just 90 degrees, and that equals change in theta over change in time. Whoops, sorry about that. So you do a little number crunching. Just a moment. So that ends up being 11.1 meters per hour. So there you have it. Hope that was helpful to somebody at least. Rates of change. Good luck, everybody.